Hey everybody, I wanted to give you guys a quick overview of my energy storage system and my solar, how it all combines, what it looks like. The landscapers are out this morning, so I apologize for any loud trucks or things. I'll try to edit that out as best I can. But I just want to go over some key points of what you can expect as a homeowner or as an installer or a system designer. That works on these things or has to figure out where they go. Just some good information for you guys to have. And I do talk about this in my book a little bit as far as the layout stuff, right? But this is a pretty representative example of what you're going to see or install or design around, yeah? So let me go over the main parts of this energy storage system. I'll pop the cover off and then bring the camera in and we can take a closer look. All right, so the first component I want to talk about is the power electronics or the battery inverter. Now, this particular Sonnen model has the power electronics and the batteries all in one self-contained unit. You may or may not have a system that looks like this, but all of these systems will have the same components. They just may be separated, okay? So this is essentially, so what we're looking at here is the battery inverter. It is connected to the grid. It's also connected to a sub panel, which you can see right over here, right there. So all the loads in my house have been shifted from the main panel to this sub panel, except for my electric dryer and my air conditioner, because they're just so big I didn't want to really stress out my battery system. So the main purpose of this device is to take excess solar or the grid to charge the batteries and to take the battery power and convert it into AC to power our home. Oh, and we can see that that's actually kind of neat that this happened. The lights are actually telling you something, right? So a yellow light means it has lost connection with the internet. And I experienced that today while I was having a meeting that I kept cutting out. Last night, my kids and I were gaming and we kept getting disconnected. So there's probably some kind of internet thing going on in our neighborhood. But as you can see, it already fixed itself. All right, so that's the power electronics. Let's look at the batteries real quick. So these are lithium ion batteries. More specifically, they are lithium iron phosphate or LFP. It's just a different type of chemistry that this particular battery manufacturer uses. There's another one called NMC. There's also NCA. You'll see it in different manufacturers. And there's pros and cons to each chemistry. But in general, the LFP seems to have a safer chemistry as far as thermal runaways, and if you puncture it, it won't catch on fire, higher ratings for heat, all that stuff. But I don't really harp on that because I don't want to give the impression that any battery system is unsafe, because there are plenty of controls inside these things to keep everyone and the equipment safe. So this particular battery module is 5 kilowatt hours, and I have another one underneath. So this is a 10 kilowatt hour system, and it's able to put out 4.8 kilowatts of continuous power. Okay, so now I'm going to talk about some of the other stuff that you see here. This is all called balance of system components. And again, every energy storage system needs this stuff. It's not pretty. Some installers will paint it to match the walls, but kind of at the mercy of all this ugly gray equipment in one way or another. Yeah. So now what you're going to notice is that my system may or may not have all the components of another energy storage system manufacturer. There's things that are built into this one that you may have a separate box for if you're going to do like a Tesla or an Enphase system or something like that, right? Specifically an automatic transfer switch. I think some of them call it a backup box or whatever terminology they use. It's basically a box that has an automatic transfer switch in it that will allow the system to isolate the microgrid, solar and the battery power from the main grid, right? We can't have any of that stuff backfeeding. The Sonnen solution has this internal switch built in to this, so I don't need a separate box for that like some other manufacturers do. And not a big deal, just one of the many differences we have out in the industry, right? So I always like to start from grid side and work my way to the right. And when I installed this, that's exactly how I had it set up. Yeah. So this box right here is actually a pass-through box from my main service panel. On the other side of that is my main service panel, my breaker box, can, whatever you want to call it. And there's only a few breakers in there. The breaker that feeds my ESS, the breaker to my air conditioner, and the breaker to my dryer, my electric dryer. That's it. Okay? So all of the circuits in my house have been rerouted through this box. So I push the camera out a little bit, but we come through this box, up that conduit, into that gutter across the top. Right? And gutters are useful because you can just pile a bunch of stuff in there, right? So we actually come in there and eventually we end up in this sub panel or essential load panel, protected load panel. Never call this thing a critical load panel because that's not what it is. And I go round, it's the same platform that I get on when I talk about people who call the things on the roof panels instead of modules. Like, I know I've lost that fight, but I'm still going to fight it. However, if you call this a critical load center, you are wrong because it's not a critical load center in the sense that you think it is. The National Electric Code has very specific litany for critical loads. And 99% of the houses out there, 99.9% of the people that call that a critical load panel are using the incorrect term. I'll just tell you that right now. So I have all the other loads in my house shifted over here, and my solar breaker is also in this panel. This is a panel, right? The things up on the roof are not panels. Okay? So stickers, red stickers everywhere, right? Got to have labeling. Got another red sticker right there that denotes this breaker is to my PV system. Yeah? And if you think there's a lot of BOS out here, wait till you see what's on the other side of this wall with the solar and all that stuff. Like that, it's just a mess, man. All the stuff they make us put in here is crazy. So let's look at the outside, and then I'll show you a flow of the energy. All right, so here we are on the side of my garage. You see my SMA Sunny Boy 5,000 watt string inverter, and you can see the conduit that comes down from the roof from my array. Has 16 modules up there. I think they're Jinko 320s. Underneath each module I have a Tigo TS4F module level electronic for rapid shutdown compliance. You can see a lot of piping, a lot of stuff over here. I mean, you can see disconnects and red labeling and just stuff everywhere, right? This is just, you have to have this, okay? So the PV inverter here takes the DC coming down off the roof, converts it into AC, and then sends it in here to this box, and it actually goes through the wall here into my sub panel where I showed you that breaker before. Okay, so it comes down, is converted here, and then goes into the sub panel of my home to start putting in all that clean green energy.